Cool. Welcome in, everyone. One of our first official classes to kind of get a little grounding on these units that'll be real essential in our class. One of the big things I wanted to show you guys is one of these cheat sheets, in a sense. Y'all actually have them we have them in our bookstore as well. So this one is all about physics, and I saw some other, there might be like a biology, like one sheet, or some of the other type of one sheets, but they have a whole bunch of conversions and equations and different things that can really help you out. So that's something real good because it's a real good way to study. Say that again.
I'm gonna go get one here and bring it.
Yeah. They have different subjects, so I definitely suggest getting one of those. It really helps out because we might, like a lot of times on tests, we'll give you things like this. So it's a real good way to see, oh, okay, use this equation, but they'll also tell you, oh, use this equation if you're trying to see the refraction of light or the reflection and refraction of light. Oh,
yeah, you just gotta remember which one to plug in.
Right. So they do a pretty good job telling you, like, look at this angle, check out section 1 and then 2 and 3. So that helps out a lot because there's a lot of numbers, a lot of equations, a lot of constants. Constants are things that are always staying the same, like the speed of light constant, things like that. So you might not remember, like, man, is it 3 times 10 to the 7? Like, is it 3 times 10 to the 9? Like, okay, well, it's a constant that should be given to you a lot of the times, but it's a good way to study and have some things given to you that's a pretty easy way to study. And then that's physics 1 and physics 2, so a lot of times it'll be pretty comprehensive. But before I get started, anybody have anything that they'd like to share, anything that stood out to them that maybe you went home and was like, man, I see what Mr. Gordon's talking about, like anything that you went home and
No comment. I understood the syllabus. I have no further questions.
Yeah, I understand. Yeah, no problem. Definitely physics is all about understanding the natural world and understanding the universe around us. So to look at different ways that you can relate to it and build some confidence, I definitely promote that. So cool. So one of the big things with our problem set 1 are units, understanding units. Of course, 1.1 just explaining a lot about the history of science and some of the different subjects that are going to be a good stepping stone to understanding where we are now, like how Newton figured out certain things, or how ancient people used to use certain angles to tell the time, using the sun to understand different angles and understanding different shadows. There's also different pigments, like I was talking about the colors, and they were able to say, okay, why is this red, why is this blue, and then understanding, oh, okay, in the future we're able to say, man, this is exactly what it is in the lab. But they didn't have the lab back then. They were able to go out and go see, when we use this certain medicine or use this certain herb, it responds to your body a certain way. So I'm sure you all could relate to that as biology students, you know, checking in with different electromagnetic frequencies, which is what we were talking about last time. So also, you know, there's a wide range to the spectrum. You got different subjects, like our first one would be projectile motion, and then there's also mechanics, behavior of light. We won't talk about light too much. We also don't talk about the electricity and magnetism in physics 1. Electricity and magnetism would be physics 2. Thermodynamics, we will talk a little bit about thermodynamics. So that's real cool, about understanding heat change. Thermodynamics, understanding the change in heat. So we'll talk a little bit about that. Yeah, measurements. Cool. So with the units, so we have a question like a car traveling at a speed of 33 meters per second. What is its speed in kilometers per hour? So car. So when you look at these questions, pretty much everything is going to be in the question. Whatever you need to use, they're going to tell you what it is that you need to plug in or that you need to use. So something like this question, how do we get from 33 meters per second to kilometer per hour?
I'm gonna do like meters times some times like Greece.
Mm-hmm.
So you got to combine them all over the body things. And times, is it kilometers over seconds or something, and then times the hour?
Mm-hmm. So you were right. So you said something over meters. So how many meters
Yeah, we gotta cancel these.
are in 1 kilometer? How many meters is in 1 kilometer?
Is it 1,000?
Yep.
Is it 1,000?
How? Yep.
1,000.
So 1,000.
What is it?
Well, 1 kilometer is 1,000 meters. So one of the hardest parts is knowing, is it gonna be on top or bottom? So and then you could say, well, what if I did do it the way I was about to do it? And I said times 1 meter is 1,000 kilometers.
You won't be able to cancel it out for
Exactly, yeah. Because then I'd have meter squared
yeah.
over kilometer, so that doesn't make any sense. So that's why units is really important, because it can tell you what your answer may be. So then I got
And
1,000, so and then I would do, so we got that like you said, and then I would do 33 divided by 1,000. So and then that'll give me kilometer per second. So what's that, like point 0.33 or point 0.033? So and then that's kilometer per second. And then how would I change that second to hour? So I got 1 over second. So now I'm trying to get hours on the bottom. So and then if I want to cancel out seconds, I'll put the seconds on top.
you do 60 seconds.
How many seconds are in 1
over an
minute?
hour.
Well, I'm not quite at an hour yet, because in between the seconds to hours is a minute. So I do there's 60 seconds in 1 minute. And then in 1 minute, there's 60.
It's okay, so you don't make it.
60. So and then in 1 hour, there's 60 minutes. Alright. And then got that canceled out, got that canceled out. So now I just do 60 times 60, which I believe is 3,600. So now I'm able to say up here, 9,033 times 3,600 should give me 1 kilometer per hour.
Oh yeah, keep up these.
Yeah, units is one of the things that gets annoying, but once you just cancel them out and able to get to the next, like breaking it down incrementally, you can break it down a little bit more simply, and that's gonna give you the way. But then I would rather have it like all in one, where I'm just putting it all together, so I don't have to do it like twice. But yeah, that's how we would look at that one. So then looks like I have college football game is played on a 100-yard long field, excluding the end zones. How long is the field in meters? It's given that 1 meter equals 3.281 feet. So then I have to convert feet. So yeah, the big things with this unit are those cross canceling out each other. College football game played on 100 yards. So I have a lot of times it'll help out to draw a little picture to help you out sometimes. Because like we were saying, it helps out a lot to have a visualization what it is. So a college football game is played on a 100-yard long field, excluding the end zones. How long is the field in meters? 100-yard field. Question in meters. How long is it in meters? It's given 1 meter. 1 meter equals 3.281 feet. So now if I'm setting it up, what is given 100 yards? What do they want? They want meters. A lot of times, we'll just put it at the end, because that's what they want us to get to, is meters. So now I got to figure out. They're telling us the footage. So now I gotta see how many feet are in 1 yard. Because they're telling me that the footage, 1 meter, is 3.21 feet, 281 feet. So in order to cancel out my feet, I need to see what feet is right here. So and then, if I go to mine, a lot of times it'll be given. So a lot of times we'll have to look it up. What was that?
So we'll say 1 yard equals 3 feet. So you put the 3 on top.
No, that's telling us that 1 meter equals 3 feet.
Like there's 3 feet in 1 yard.
Yeah, that's true. I wonder why they say 1 meter. Where am I? Where are my units? Well, yeah. What is 1? 1 meter. That's 1 yard in meters. Okay, so I was like, let's put in that 1 yard. Update that 1 yard.
Nah, it's lagging. Nah, I had to take another month IT yesterday. He fixed it.
So how you do that to the Wi-Fi?
He put me on the AMSC, not the conference one. It's supposed to be the regular one. And you gotta log in with your credentials for here. But don't put in all things, just put in like the username part and then your password.
Okay. Thank you.
Yeah, so 1 yard. Meters. How many feet? Alright, 1 yard. So 1 foot. Yeah, so I can put that there. 1 foot is in 1 yard. So now I'm trying to see how many feet are in 1 meter. So and then 1 meter. How many feet is in? And then 1 foot equals 0.3. 0.30 meters is in 1 foot. Alright, so here's how it is. Hey, welcome in. Yep. Treasure, right?
Yep.
Cool. So we got 100 yards, and we're trying to figure out how many it is in meters. So, of course, we're able to cancel out our yards, and then we're gonna want to multiply 100 times 3.281. So then we get feet and feet canceled out, and then we're left with meters, which is what we want. So I'm looking at 100 times 3.281 times 0.3. So that should give me like 98.4. Talking about soccer field. Oh, we already did one. Meters. Let's see if there's another one. One drive all day. The speed of sound is measured to be 343 meters per second. What is this speed in kilometer per hour? So we talked about that. Meters per second is going to kilometer per hour. Suppose that a scale reads the mass of a box at 45 kilograms with a 3% uncertainty. What is the uncertainty of the mass in kilograms? So uncertainty, so there is an equation where we're understanding. So we have precision, accuracy, and also precision and accuracy. And so the way that they explain, so we're looking at uncertainty. So the way that they have precision, accuracy pointed out, they use a target. So and then I'm looking at precision. So precision is going to be exactly how precise are you. But it doesn't mean that you're accurate. So accuracy, of course, I'm going to want to get close to here, right? So if I have a few different places, boom, 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 you know, I'm pretty accurate. I'm not all the way there. I'm pretty accurate. And then if it's something like that, you know, now I'm losing out on my accuracy and my precision. But then if I'm doing it again, and then I have a lot here, I'm precise. I have a lot that are in one place, but it's not accurate. So that's kind of the difference between like precision and accuracy. So with uncertainty, I might say, okay, I'm this distance away. You know, I might say I'm 2 centimeters away from the bullseye, but it's plus or minus, you know, it's plus or minus 2 centimeters. So that's where our uncertainty comes from. It's saying, okay, well, I'm somewhere in this range.
Right.
So, yeah.
I said it's like just a general area.
Mm-hmm. Yeah, so that's how our uncertainty comes into play. So there's an equation that they use for uncertainty, which has to do with also with 1.3. So your first problem set will be on 1.2 and 1.3. So it's units, accuracy, precision, and significant figures. So if I'm looking at, alright, percent uncertainty. What is my percentage of the uncertainty? So that's why we're going to use percent uncertainty is equal to delta A over A. So that delta is just looking at the change in A times 100%. So I'm just looking at so what they use in our textbook, calculating percent uncertainty using a bag of apples. So then I have different weights that a bag of apples is. £4.8, 5.3, 4.9, and 5.4. It's kind of ugly. Alright, so I have weight number 1. So I'm looking at understanding what is my percent uncertainty of my measurement of the bag of apples. You know, so of course want to look at the expected value. So that's what the A is. It's our expected value. So I want to say, okay, my expected value is supposed to be 5 pounds. It's supposed to be 5 pounds. But then I have the uncertainty in the value DA. So let's see here. So it's supposed to be, yeah, what I could say equals. So I'm gonna say 5 pounds. It's supposed to be 5 pounds. But then I have an uncertainty. So what's my change in the pounds? So I'm gonna say, okay, from 5 pounds, how much does it get? What's my span? You know, what's my span of getting away from that 5 pounds? So then I'm just gonna add, okay, well I got 5.4 here, and then I got 4.8. So from 5 minus 5.4, I got 0.4. You know, from 5 minus 4.8. Of course, I'm doing 5, you know, kind of absolute value or whatever. That sign, absolute value. 5 minus 4.8. So then I'm only 0.2 away. You know, 5 minus 0.3. You know, I'm gonna get 0.3. 5 minus 4.9, I'm gonna only get 0.1. But my largest amount of variation is gonna be the 0.4. So of course I'm gonna put that right there. The change of this A is gonna be a 0.4 amount of change.